All right, today we're going to dive deep into the invisible shield that makes elevators one of the safest ways to travel on the planet. And thanks to some great insights from the experts over at Navanpuya Elevator, we're going to break down the absolutely brilliant safety circuit that protects you on every single ride. You know, have you ever really stopped to think about it? What is it that makes riding in an elevator so incredibly safe? We all do it pretty much every day without a second thought, but the technology that earns that trust, well, it's truly fantastic. The secret, it turns out, is all about this incredible, powerful, but totally invisible safety chain. Think of it like this. It is an all or nothing deal. If even one single link in that chain isn't perfectly secure, the elevator simply will not move an inch. So the technical name for this is the safety series circuit. It's built on a really simple but clever principle called normally closed. Just picture a complete circle, a continuous loop of electricity. For the elevator to move, that loop has to be complete. But the very second any safety switch detects a problem, it opens up, breaking the loop and instantly cutting power to the motor. It's that fast. Okay, so how does this amazing chain actually work? Let's break it down link by link, and we'll start with the parts that we all actually see and interact with. First up, we've got the guardians of the doors and locks. Now, this is probably the most relatable part of the whole safety chain, right? It's all about making absolutely certain that every single door is securely shut before that elevator even thinks about moving. So we're going to look at three key pieces here: the landing door locks, the car door switch, and the landing door lock contact that ties them together. All right, first up, the landing door locks. You can think of these as the ultimate bouncers at the club. They send one simple, non-negotiable message to the system. I will not give you permission to move unless every single landing door in this entire building is physically locked shut. No exceptions, period. So, once all the outside doors are confirmed locked, what's next? The car door switch. This performs the final check, making sure the door of the car that you're actually standing in is completely closed. If there's even the slightest gap, that circuit stays broken. And this part is just genius, because it shows how the physical and electrical systems work together. The landing door lock contact is basically the electrical proof that the mechanical lock has done its job. So when that heavy physical bolt slides into place, clunk, this little contact closes, and that completes its link in the electrical chain. It's like a perfect handshake between mechanics and electronics. With the doors secured, the next links in our safety chain are the sentinels of motion and speed. Think of these as the elevator's own internal senses, constantly monitoring its position and its speed inside the shaft. In this section, we're going to cover three critical devices: the governor switch, which watches the speed, and the final limit and buffer switches, which keep an eye on the car's position. The governor is pretty awesome. It's like the elevator's speedometer and its emergency brake all rolled into one. If the elevator starts moving too fast for any reason, the governor detects it immediately, opens its switch, and breaks the safety circuit to stop the car cold. Now, the final limit switches, these are the absolute last line of defense. They're placed at the very top and very bottom of the shaft. If the car ever happens to move beyond its normal stopping points, these switches trigger and cut the power, preventing it from going any further. Way down in the pit at the bottom, there are these things called buffers, kind of like giant shock absorbers. Now, if the car ever makes contact with them, the buffer switch is activated. And here's the clever part. It doesn't just stop the car, it also prevents it from being restarted until that buffer is back in its normal position and the whole system has been checked out. The next links in the chain are all about human intervention. The emergency and manual switches are there to give technicians and emergency personnel direct, hands-on control over the safety circuit exactly when they need it. So here we're talking about those iconic big red stop buttons, placed in strategic locations, and also some really smart switches that monitor the health of the governor system itself. These stop buttons are absolutely essential for keeping maintenance personnel safe. There's one in the pit at the very bottom, another on top of the car itself, and often one in the control panel. A technician can press any of these to immediately break that safety circuit and halt the elevator, ensuring their own safety while they work. And this is a fantastic example of redundant safety. So not only does the governor monitor the elevator's speed, but the governor rope switch, it monitors the governor itself. How cool is that? If the rope that connects to the governor system goes slack or breaks, this switch activates and stops the elevator because its number one speed sensor might be compromised. So you can see how all these individual components come together to form one powerful interconnected system. But that system, well, it's only as good as the parts it's made from and the expertise used to install it. And that, right there, is the final crucial link. Let's just walk through how it works in real time. First, during normal operation, a continuous electrical current is flowing through that whole closed safety chain. Everything's happy. Then, a fault occurs. Let's say a landing door latch just doesn't engage properly. Instantly, the chain breaks. That door's switch opens the circuit. The result? Power is cut, the current can't reach the safety relays anymore, and finally, the elevator stops. Power to the motor is cut and the elevator comes to a safe stop. It's just that simple and that effective. And this philosophy is summed up perfectly right here. Every component in this chain plays its vital role. You see, in a series circuit, there is no single most important part. Every switch is equally critical because the failure of just one of them means the entire system stops. And paradoxically, that's exactly what makes it so incredibly safe. And that really leads us to the ultimate takeaway from all of this. An elevator's safety system is only as strong as its weakest link. It's an old saying, but it's absolutely true here. This is why using high-quality, standardized parts and relying on the deep expertise of professional technicians isn't just a good idea, it is absolutely non-negotiable. Our deep dive today was really made possible by the expertise of the team at Novan Puya Elevator. It's their commitment to the highest safety standards in designing and maintaining these crucial circuits that's the reason systems like this work flawlessly. If you ever need professional consultation, you can reach them at the website and number right there on your screen. Thanks for joining us.